So it is day 2 of the Engineering Design Show 2025 here in Coventry. And on our podcast stand, I have with me now Pierre from EPs. And for members of our audience who are unfamiliar with EP's brand, can you just give me a very quick summary of what you guys do?
Thank you for having me first. I'm Pierre JLP. I'm in charge of sales for Europe at EPs. EPs, basically what we are doing is providing unlimited battery life by charging devices with ambient energy, and most of the time it's light. We are a Belgium startup, little bit more than 10 years old, over 40 employees. And we are providing a power management chip for energy harvesting, taking any kind of energy source. Again, most of the time it comes from photovoltaic cells. Charging a storage element, like a battery or a supercap or a heated cap, and then fueling the application.
I can see you brought some products with you.
Yes.
So can you just give us a little bit more technical depth? Maybe show me what you've got there.
Yes. So our biggest success is the Samsung remote control.
Okay.
It's battery-free remote control. We have been working with them for several years already, and we'll continue to do so. We are selling millions of those.
Nice.
So it's really successful. We also have wireless keyboards, for instance, in the consumer space. And then moving more to the IoT space, I brought also these BLE tags that are used in the industrial environment for work orders, monitoring, for instance. So you can stick that on a box, and it's indoor geolocation inside the factory.
Right.
So that is a good use case. And again, it's unlimited battery life because it uses light to recharge a very small battery.
Right.
The other example is this temperature sensor. That is from Nodon, and that is, it's a Zigbee temperature sensor, except that it has unlimited battery life thanks to this PV cell, photovoltaic cell.
Yes, it's interesting in sort of industrial IoT applications, although companies are reducing the energy requirements of those circuits, the battery is still always a concern. So my guess is that by deploying this, you're taking away that long-term concern in terms of battery.
Yes, exactly. We believe that batteries are somehow killing the scaling of IoT. And because even if you have to change the battery once, it's already a huge cost, because it's not only the cost of the battery itself, but also the cost of replacing it. There's a maintenance cost. So actually, we do that for 2 reasons. One is zero maintenance. I think that's the one that customers like the most. And the other one, of course, is to reduce carbon footprint. With a remote control, for instance, we reduce by 40% the carbon footprint compared to a battery with control. So I think it's both for the planet and to enable IoT scaling. This is really important to go in this direction.
Yes, it's interesting. On our pillars of sustainable design, sort of product durability and minimizing maintenance and repair are 2 very important pillars. A lot of IoT, I guess, is often in remote locations, far away. So to change a button cell, you might have to drive 100 miles and spend a day climbing a mountain to get to the sensor you need. So I get that. It was interesting. You mentioned something at the beginning there that you can charge supercapacitors rather than batteries themselves, because I'm seeing a lot of supercap, moving into areas where batteries previously were. Do you see that as a trend?
Yes, both on the storage element side, we can use any technology. So of course batteries, but batteries, they don't need to have lithium. There are other technologies, and also supercaps. And there's also kind of in between with hybrid caps, like lithium capacitors that have less leakage than supercaps that are used also. So really depending on the use case, we are recommending our customers which type of storage element fits their use case.
Interesting.
And we do the same for the photovoltaic cells, because all of this is possible because of the recent progress of the photovoltaic cells with all the different technologies. There are 4 or 5 different technologies for indoor, for outdoor. Some are hybrid, and they have very good performance, and that's what is enabling these use cases. So same thing, we sell only the power management chip, but we are helping our customers for the end-to-end system.
Right. Yeah, that was one of the things I was going to ask. Your intellectual property is in that chip. That's your specialist skill.
Exactly.
But you've got design capacity to help customers integrate that into their product. Yeah.
Yes, that's correct. So I think EPs is seen as a kind of pioneer and expert in the energy harvesting and especially the power management. So as you said, our IP is really the power management for energy harvesting. Since more than 10 years, we are recognized for that. But yes, of course, to accelerate projects, to help our customers, we support them end to end. So as I said, recommending a harvester. So most of the time is a photovoltaic cell, but it can be thermoelectric generator, it can be a wireless charging, so kind of radio harvesting. It can be a pulse. Also, we have buttons. So it can be different types of energy that we will take as an input. Clamps on electric cables as well can harvest energy. So we have lots of options for harvesting energy, and then same thing on storage element. We also help them really end to end to accelerate projects.
Yeah, so endless opportunities to find the energy you need to keep those devices alive. Yeah.
Yes.
How do people get hold of you? How do people get involved in this? I'm assuming you have a website that people can reach you, and you have engineers that can go visit customers.
Yes, of course. So they can reach out to me. We can share my email, of course, my details. We have a website with all the data sheets. We have evaluation kits. So people can start the design also with evaluation kits. And we have FAEs that support our customers. I think their support is appreciated.
Yes.
As I summarize, the way to start a project is really to tell us the size of the device and the power consumption, so that first we can say if it's realistic or if it's a dream. It will not happen, but in many cases it's realistic, and then we will also immediately tell them the luminosity and time of exposure that the device needs to be autonomous. So let's say for instance 200 lux for 8 hours per day, or something else, depending on the use case.
Brilliant. We will point people in your direction and advise them just that. That's brilliant. 2 very quick closing questions. Your engineering hero of all time, who would you choose?
That's a challenging question. So my background is more mathematics, so I think disciplines like maths and physics are very important. So I don't know. I say Pythagore for maths. Because I think that's the basis of everything somehow. And it's also maybe for students today good advice to focus on this fundamental science. Because AI will do a lot of other things, but probably not that.
Brilliant.
So
Yes. And one invention you wish you'd invented.
Well, related to what I'm doing on a day-to-day basis, I think the photovoltaic cells are really kind of magic.
Yep.
It's not one invention because there are 4 or 5 different technologies.
Yeah.
So it's different chemistries, but I find it fascinating because it really enables great use cases that is good for the planet and good for the IoT scaling.
Yes, a brilliant invention, sustainable to finish on. So thank you very much for your time here. Thank you for explaining all of that. And we'll let you get back to the show.
Thank you very much.